Very good day, students. So today we are taking up a very small topic in the muscle mechanics, and this is about the speed of the muscle contraction. So students, previously we have discussed in the last lecture that the tensile force which is generated by a muscle, it depends upon the width of the muscle. So if I have to give you the overall idea of the tensile force, so the tensile force will be proportional to the width of the muscle. So we can write here as like muscle organ. So more is the width, more it has got the physiological cross-sectional area, and more will be the tensile force generation. Now if I take one example, suppose we have a muscle which is just like this. So this is the muscle M1, and we have another muscle which is M2. Now it has got the width W1, and the muscle number 2 has got the width W2, let us say. Now here the width of the muscle number 2 is greater than the width of the muscle number 1. So here the W2 is greater than W1. So when the width is more, and if we take the cross-sectional area of this particular muscle, that will be more than the first muscle. Now if I make it like 3-dimension, if I am making a muscle just like this, to just give you an idea of the cross-sectional area, so this will be the TS of that muscle. If I take the upper portion, that will be the TS. Now if we compare this area with this area, so that is always like larger, that is more. So what I want to say over here is that the area with muscle 2 is greater than the area of muscle 1. So what will happen, that the muscle number 1, it will produce less tensile force. So I am writing as like TF2 will be greater than TF1. That means the tensile force generated by this particular muscle will be greater than this muscle. Now students, here we are talking about the speed of the muscle contraction. So this is very important thing, that making like tensile force or the magnitude of the tensile force made is something else, but the speed of the muscle is something else. So if I have to like compute the speeds of these two muscles to contract, so we take one criteria, that uh, we have to like go with the time taken by the muscle to contract to its half of the length. Now this will be the half of the muscle 1, and that will be the half of the muscle 2. So whenever the first muscle will contract up to this level, the time taken will be, suppose the time taken is T1. So this is for the muscle number 1 to come to the half of its length. Now what is T2? It is the time taken by the muscle number 2. Now what do you think, that will the T2 will be equal to T1, or T1 will be like greater than T2? So as we have already gone with the particular case that the tensile force in the second muscle will be greater than the tensile force in the muscle number 1. So the time taken by T2 will be shorter. So it will take less time to contract to the half of its length because it is making more of the tensile force. It can produce more of the force due to its large physiological cross-sectional area. So this is a comparison of the two muscles with the different widths. So we have width 1 of one muscle and width 2 of the another muscle. But what will happen if you have two muscles with equal widths? Now we have to compute the speed of muscle contraction in that particular case. But in this particular case, we have the muscle number 2 with greater speeds of contraction because of higher tensile force strength than the muscle number 1. Now students, we are taking the second case. Now in this case we have two muscles. This is the muscle number 1 and this is the muscle number 2 with the same widths. So this is the very important thing, that if this is the width of the muscle number 1 and we have the width of the second muscle as W2, then what we have over here is that W1 is equal to W2. Now students, if the widths of both the muscles are same, that means if we cut this muscle into a TS, then both of these muscles will have the same cross-sectional areas, whether it is morphological cross-sectional area or it is physiological cross-sectional area. So that means both of these muscles will be producing the same tensile force. So we can write as like TF1 is equal to TF2 in this particular case. Now students, here what my question is to you is that if both the muscles, they are of the same width, they are producing the same tensile force, then can there be any effect of the length of the muscle? Now if I take, suppose, this particular length as L1, this is L1, and we can have the length of this muscle as L2. Now here we have L2 is greater than L1. Now again, in this particular case we have to compute the speeds of the muscle contraction. Now it will be taken as what will be the time taken by these muscles to contract to their halves. So half the length they have to contract. Now the time taken for the muscle number 1 will be, it is taken as, suppose it is T1 and the time is T2 for the second muscle. Now because in this particular case the tensile forces are the same, now what will happen? Now suppose if you have a ground, so this is a ground and you are a sports person and you have to reach up to this point. Now one student is starting from this point and he has to reach up to this circle in the minimum time, and one student is starting from this place and both the students, they have to reach this particular place in the minimum time possible. Now suppose if both the students, they are reaching this place in the same time, so both the students are taking the same time to go to this place, then the speed of the second student will be more than the speed of the first student. So this is the inference. So if they are like going up to this level at the same time, this student will be having more of the speed. Now, in this particular case, in the case of the muscles, the T1 and the T2, because the tensile forces are the same in both the cases, here the T1 is equal to T2. So both of these muscles will reach their half of the length in the same time. So that simply gives you the answer that the speed of the muscle number 2 will be greater than the speed of the muscle number 1. So students, in this particular case, the speeds of muscle number 2 will be greater than the speed of the muscle number 1. So that was the concept that you have to like learn from these examples. Now if you have like two different muscles of two different widths, more the width, more will be the speed of the contraction. That was taken in the previous case. Now in this particular case, you have the equal widths, W1 and W2, they are equal. Tensile forces will be equal due to cross-sectional areas, similar cross-sectional areas. So in this particular case, if the tensile force is the same, time taken to reach the half of the length will be again the same. Now if it is same, then the speed of the muscle 2 will be greater than the speed of the muscle 1. So that was all about the speed of the muscle contraction. I hope you have understood the topic.